Hello grade 11, welcome again in our online sessions with you, Mrs. Minna Raouf, your chemistry teacher. I hope you are all fine and everything is okay with you. Today we will start our new quarter with chapter 18, organic chemistry. First, what mean by organic chemistry? Organic chemistry is a chemistry of carbon compounds. So, the organic chemistry is the chemistry of carbon compounds. Organic compounds are any chemical compounds that contain carbon. So any chemical compound contain carbon, this is called organic compounds. Why specific carbon? Because carbon has the ability to form long chain. So we choose carbon because carbon has ability to form long chain. And it's called organic compound because they are associated with the living organism. If you look around you, every day, anything around you is organic compound. Your food, your clothing, furniture, and the plants all contain organic compounds. Today in this section we will talking about a class of organic compound called hydrocarbons. And the hydrocarbons is organic compound composed only of hydrogen and carbon. So the hydrocarbons, from its name, hydrocarbon, hydro from hydrogen and carbon, so it consists only hydrogen and carbon atoms. The hydrocarbon is less than water and used as fill and solvent in paint removal. We have two types of hydrocarbons, saturated hydrocarbons and unsaturated hydrocarbons. So we have two types of hydrocarbons, saturated hydrocarbons and unsaturated hydrocarbons. And the hydrocarbon classes of three main groups, alkanes, alkenes and alkynes. Alkanes, alkenes and alkynes. This is the three main groups of hydrocarbon. And the two types is saturated hydrocarbon and unsaturated hydrocarbon. What's the difference between saturated hydrocarbons and unsaturated hydrocarbons? Saturated hydrocarbons contains only carbon-carbon single bond. So the bond all in the saturated hydrocarbons is single bond. But in unsaturated hydrocarbons contain double bond or triple bond. So the single bond hydrocarbons is called alkanes. And alkenes when we have double bond carbon. And alkynes when we have triple bond. So the triple bonds called alkynes, double bond called alkenes, and single bond called alkanes. This is the three main groups of hydrocarbon. This is the difference between alkane, alkene, and alkyne. Here we have all the carbon-carbon bond is single bond. Here we have the carbon-carbon bond is double, and here we have the carbon-carbon bond is triple bond. What's so special about carbon? Why carbon? First, because carbon has the ability to form 4 bonds. So the carbon can form 4 bonds and the bond carbon are very strong and non-reactive. So carbon can bond to 4 other atoms and the bond of the carbon is very strong and non-reactive. And also the carbon can form or attach together to form long chain. So that's I told you before that the carbon can attach together to form long chains. And also they can form rings. So the carbon atom also can attach together to form rings. And also carbon can form double bond, single bond or triple bond. So why carbon? Because carbon can attach with other 4 atoms and the bond of the carbon are strong and non-reactive. The carbon can attach together to form long chain, can attach together to form rings, and also can form single or double or triple bond. The first main group of hydrocarbons, the alkanes. The alkanes has structure formula CnH2n plus 2, where n is an integer number. Alkanes is saturated hydrocarbon, and I told you that it contains carbon-carbon single bonds. They can have a straight chain or branched chain or rings. So the alkanes may be straight chain, branched chain or rings. For example, we have here methane, ethane and propane. And also the alkanes can form rings, and most common rings contain 5 or 6 carbon. This is a cyclopentane. Pentane here, pent according to 5, and hexane contain 6 carbon. So for example, cyclopentane and cyclohexane. And also the alkanes can be written in a condensed structure formula. What's the difference between the structure formula, the normal structure formula, and condensed structure formula? The normal structure formula of, for example, of butane is when you draw the bonds between the carbon and hydrogen and draw the chain. But the condensed structure formula without drawing the bond or without drawing the chain, like this one. We just write the formula by the number of carbon and hydrogen only, without drawing the chain. This is the difference between the structure formula and condensed structure formula. Okay. Now, how we can name the alkanes, the nomenclature of the alkanes. We have two types of alkanes, unbranched alkanes and branched alkanes. First, unbranched. In unbranched, naming is according to the number of carbon atom. The IUPAC names of unbranched alkanes according to the number of carbon atoms. So here we have one. We have here 1 carbon, 2 carbon, 3 carbon, 4 carbon, and so on. This is according to the structure formula CnH2n+2. So CH4 here it called methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. This is the IUPAC name for unbranched alkanes. For example, we have here CH3, CH2, CH2, CH3, and this is unbranched alkanes have 1, 2, 3, 4 carbon, so this name will be butane. The another type, the branched alkanes. How we can name the branched alkanes? Alkane with branched chain are named on the basis of the name of the longest chain. So first I will choose the longest chain of carbon atom in this molecule. And I will make the numbering from the beginning and end to close the branch. So I will choose first the longest chain, and the longest chain is called parent chain, and the branch is called side chain. So we have here the main chain or the longest chain that called parent chain, and the side chain or the branch. For example, I have here this compound, and I will choose the longest chain here. Why I didn't choose this one? Because this is consists only of 3 carbon, but this is the longest chain, consists only 4 carbon. So this is our parent chain, and this is, I will choose this as the side chain. This is the first step. After that, the numbering. I will numbering from the carbon atoms that close to the side chain. So I will go to the side chain and I will choose the carbon that will close to the side chain, and I will begin the numbering from it. So here I will begin the numbering from this carbon. 1, 2, 3, 4. We have 4 carbon. So it will called butane. First I will name the parent chain first. It consists of 4 carbons, so it will be butane. And the branch or the side chain here have only 1 carbon. When we have only 1 carbon, I told you that it called methane. So, but it not CH4, it will be CH3. It lose 1 hydrogen to form the bond with the longest chain. So I will call it methyl. And this methyl group on the carbon number 2. So I will call it 2-methyl butane. So first I will name the longest chain, and after that I will name the branch or the side chain, and I will write the number of carbons that the side chain attached to. Second, examples. We have here first 7 carbon in the longest chain, and 7 carbon is called heptane. And I will begin the numbering from the carbon that close to the side chain. So it will be here. I will begin from here. 1, 2, 3, 4, 5, 6, 7. So the attached one at carbon number 3, and this is CH3, so it will be 3-methyl heptane. The side chain, and it changed from A to yellow. So I will change it from methane. I will call it methyl. Okay, this is the name of the side chain. How we name the side chain. Okay, some notes. If we have more than side chain, okay, how can I name them? Or how can I write the name? I list them alphabetically. When I have methyl and ethyl group in the side chain, I will write ethyl first before methyl, because E come before M. So I will write ethyl before methyl. This is the first note. If we have 2 alkyl groups are present on the same carbon, it's easy to use the number twice. When I have on one carbon methyl group and ethyl group, and this is 2 side chain on carbon number 2. So 2 ethyl, 2 methyl. I will use the number of the carbon twice. This is no problem for me. When I have 2 or more alkyl group are identical, so the same, I have 2 methyl group but at different carbon atom, but attached to different carbon atom. So I have 2 methyl, so I will use the prefix 2, tri for 3 and tetra for 4. This is the alkyl group. And for example, if I will have attached group or alkyl group at carbon 2, and this is methyl and has also at carbon 5, so I will write 2,5 dimethyl. I have 2 methyl side chain, so I will use dimethyl, and I will write before them the number of the 2 carbons that attach to the 2 methyl. In the rings, we use word cyclo, so I will use word cyclo if the hydrocarbon in form of rings, like cyclohexane. It's hexane but in form of cyclo, so it will be cyclohexane. The side chain are also called side branches or alkyl group, so I will call the side chain, side branches, all alkyl group. And I told you that their names end in YL, not ANE. Okay? And our common side chain are methyl, CH3, and C2H5, this is ethyl, and C3H7 is propyl. Okay, this is our common side chains, methyl, ethyl, and propyl. Okay, some examples for the naming of alkanes. First, here we have CH3, CH attached with methyl group, and CH attached to ethyl group, and CH2, CH3. How can I name this? First, I will choose the longest chain or the parent chain. This is our parent chain. Okay, this is our parent chain. Okay, this is consist of 1, 2, 3, 4, 5 carbon atom. So it will be pentane. This is the first step. After that, the numbering is from the close to the branch. This is the closest one to the branch, so I will make the numbering from here. So 1, this is carbon number 1, and this is carbon number 2, and this is carbon number 3. So the side chain at carbon number 2 and carbon number 3. Carbon number 2 has methyl, and carbon number 3 has ethyl. So I will write ethyl before methyl. So the name will be 3-ethyl. Carbon number 3, 3-ethyl, 2-methyl pentane. This is our first example. Number 2, we have here, I will choose first the longest chain or the parent chain. This is the longest one. It consists of 5 carbons, so it will be pentane. and the closest number from the closest one to chain here. So I will choose the numbering from carbon number 1, it will be there. And we have here one methyl group at carbon number 2, and carbon number 3 has one ethyl group and one methyl group. So there has two methyl group attached to two different carbon. And we have one ethyl group, so I will write the ethyl first. So 3 ethyl, 2,3 dimethyl pentane. This is our name. 3 ethyl first, and after that 2 and 3 dimethyl. We have 2 methyl side chain, and the pentane is the name of the longest chain or our parent chain. Here we have the parent chain. This is the longest one. This is the longest chain. And why I didn't choose some other chain? Because this is the longest one. Okay, I will choose the longest chain with branches. Okay, I will make the numbering from here because this is the closest one to the branch. This is CH3, this is carbon number 1, and we have 3 branches group at carbon number 2, carbon number 3, carbon number 4. First I will name the parent chain. This is 7 carbon, so it will be heptane. This is the name of parent. And we have here 2 methyl group at carbon number 2 and carbon number 3, and ethyl group at carbon number 4. So the name will be, I will write the ethyl first, 4 ethyl, 2,3 dimethyl heptane. This is our name, 4 ethyl, 2,3 dimethyl heptane. Note that the root or the parent chain, so I can call also the parent chain the root. So the parent chain is usually the longest possible hydrocarbon chain. Don't forget, the parent chain is usually the longest chain. If I have multiple bond, so a double or triple bond, the root or the parent must include the multiple bond. So if I have multiple bond, the root or the parent must include the multiple bond. And if I have cyclic structure, I will choose the root to be the cycle, even if it's not the longest chain. So if the cyclic or the cycle not the longest chain, I will choose it as a parent chain. Okay, don't forget this point. In the alkanes we have something called isomers. And the isomers is compounds that have the same molecular formula but different in structure. Okay, so the isomers is compounds that have the same molecular formula but different in structure. How we have here, for example, butane and 2-methylpropane. They have the same molecular formula but they have different structure. And the 2 isomers, one of them called N-butane and the other I will call it isobutane. What's the difference between them? The N-butane is the straight chain. So the normal butane is the normal chain, but the iso one has the branched. The structure has branched. So what's the difference between the 2 isomers of the butane, N-butane and isobutane? And N-butane, the chain will be normal chain or straight chain, but the isobutane has branches. And now we will talk about the properties of alkanes. Number 1, as the number of carbon atoms increase in the alkane, the melting point and the boiling point and the density also increase. So when I told you methane and ethane, so ethane has higher number than methane. So the melting point and boiling point and density of ethane is higher than the density of methane. So as the number of carbon atom increases the alkanes, the melting point and the boiling point and the density increase. And also the alkanes are nonpolar compounds. What mean by nonpolar? They are not miscible. What mean by not miscible? They can't mix with water. So the alkanes is nonpolar, that can't mix, not miscible, can't mix with water because water is a polar compound. And the alkanes is solid at room temperature. So at room temperature, the alkanes in solid state. I will stop at this point now, and I will complete the chapter in the next session. Thank you for listening. Bye bye, grade 11.